Quantum numbers are the solution to the Schrödinger equation. And although we're not going to solve that equation, we can get some pretty important information from the solutions to those equations known as quantum numbers. Now, one way we can think of quantum numbers is sort of as the address of an electron. So the first quantum number in the hierarchy is known as the principal quantum number, and it is symbolized by lowercase letter n. Sometimes the principal quantum number is referred to as a shell, and I tend to refer to it as the main energy level. The principal quantum number lets us know what the other two quantum numbers can be. So allowed values for the principal quantum number are 1, 2, 3, 4, any positive integer, and the lowest possible value of n is 1. The higher the value of n, the further away the electron is from the nucleus. So we could kind of consider the principal quantum number to be the state that we live in. Continuing on with the address analogy, the azimuthal quantum number, or the angular momentum number, symbolized by italic lowercase letter l, could be considered to be perhaps the city or the county in which you live in. So this quantum number has values that depend on what n is. The values of L are allowed to be from 0 and all positive integers up to n minus 1. So the lowest possible value of L, or the angular momentum quantum number, is 0. These quantum numbers are referred to as subshells, and chemists use letters to designate the L values. So for example, when L equals 0, we call that the S subshell. When L is equal to 1, we call that the P subshell. And when L is equal to 2, we call that the D subshell. And when L is 3, we call that the F subshell. The third quantum number is known as the magnetic quantum number. And this is signified by a lowercase m with a subscript L because it depends on the L value. And this would be your street that you live on. So the allowed values for the magnetic quantum number go from negative L to positive L, and all integers, including 0, between those two values. This quantum number defines what we know as the orbital, or what we call the orbital. And what an orbital is, it's a volume of space that an electron is allowed to be in, or where we are most likely to find one or two electrons with 90% probability. And a maximum of 2 electrons can occupy one orbital.